Question 41. Someone's done the hard meters for you. You've got your original graph, line of best fit, and you've got the residual plot. Producer of toilet tissue, weighing it up to see what's going to happen with the particular strength factor. Is it going to do the job? In other words, part A and part B are substitutions as before. I'll just quickly show you the workings for those. So here, plugging and substituting job, 39.1 millinewtons, I think that's the unit, and the weight there, micrograms in the next business. Now, what you want from a well-modelled equation that you found is a residuals plot that has an even distribution points above and below. The residual measure here is determined by the graph. So the features that we want, even distribution randomly above and below the x-axis, that seems to be reasonably well modelled. So we'd say something of that order, relatively low residuals, something beyond the course perhaps. When it comes to D, 2421 is on the original scatter plot, so that means that a 24 weight gives us a 21 strength unit. The residuals graph, on the other hand, shows us how different the value is from the modelled scenario. So what we would say in that instance, a 36 microgram tissue is 5.4 millinewtons stronger than the modelled equation predicted, slightly higher. The last part of the question, the y-intercept, very light tissues. Well, this refers to extrapolation. If we were to extend that graph back, just using my ruler in this instance, you can see extending that back gives me a negative strength figure. So that negative 6.14 is not a realistic figure and shows you just to be very, very wary of extrapolation scenarios. We can really only work within the model data. Even just slightly before or slightly after in the weight component would potentially lead us to making some potentially very silly predictions.